Well, howdy there, Internet students. This is lesson 4.2b, exponential growth and decay. Today we're going to learn how to write equations for exponential growth and decay. To help us understand how these equations work, go ahead and answer the two questions at top here. All right, you might have used a little different words than I did, but you should be seeing a linear pattern in the first table. You're adding 4 every time. And the equation for that, this is actually a direct variation, is you take the number of weeks and multiply it by 4. That's the number that you're adding every time, the slope. On the second one, you should have noticed that it's a relationship of multiplying. You're multiplying by 2 each time to get the next week's worth of flies. When that happens, it's called exponential. And the equation for this would actually be the number of flies is equal to the power of W. So like to get this number here, you would take 2 to the 6th power, which is 64. And that's because you are repeatedly multiplying by 2 in this table. So we're going to learn how to write equations that are exponential in this lesson. Okay, so quantities that are repeatedly multiplied by a number greater than 1 are said to show exponential growth or increase, exponential increase. Let's just say growth, all right, because we know that means increase, right? All right, so let's do a little lesson to help us understand this. In a land long ago, there was a ruler who, there was a peasant, which is just a regular person, who saved his daughter. So the ruler offered a reward to this person because he really was thankful that he saved his daughter. And the subject got to pick whatever he wanted. And it took him a while to figure out what he wanted, but he decided that he didn't ever want to go hungry again. So he asked for 1 grain of rice, well, actually 2 grains of rice on the first square of a chessboard. And then each day, the number of grains of rice is doubled on that chessboard. And then he would just walk away with all the rice on that chessboard. So, we're going to fill this in. So on the first square, there would be 2 grains of rice. On the second, that would be doubled, so 4. Third would be 8. Go ahead and fill this in up to the 6. Okay, so I hope you notice you're multiplying by 2. So on the 7th square, he would have 128 grains of rice. On the 10th, you're going to have to multiply by 2 3 more times. So go ahead and figure out the 10th and the 20th square, how many there are. All right, here's the numbers I came up with. We're going to need those numbers to do some calculations on the next page. For one type of uncooked long grain rice, 250 grams have a volume of about 5 cubic centimeters. What would be the volume on square 5? So we need to know how many are on square 5. I'll show you how to do that, then you can figure out the other ones. On square 5, the volume is 32 grains of rice. Now, every 250 grains is equal to 5 cubic centimeters. So let's divide that. 250 for 5 is equivalent to 50 grains per cubic centimeter. So, and a cubic centimeter is, 1 centimeter like this. So it's a volume, 3-dimensional. So it's 50 per 1 cubic centimeter. So inside that little thing will hold 50. So to figure out how many are on square 5, we know there's 32, right? We have to divide that by how many grains there are in 1 cubic centimeter. So 32 divided by 50 is 0.64 cubic centimeters. So actually 32 is less than 1 cubic centimeter. All right. So when the ruler saw that there were, oh, we're supposed to figure out square 7 and square 10. Go ahead and do that. Take the number on square 10 divided by 50 to turn it into cubic centimeters. All right, so here's what I got for that. And these are in cubic centimeters. So quite a few cubic centimeters of rice on square 10. So when the ruler saw there was about 20 cubic centimeters of rice on square 10, oops, sorry about that. This should have been square 10. This is actually square 20. So we're going to need that for this next. He thought that by the time we got to square 20, we would need to double this 20. So how many will actually be on square 20? This, and that's because you are doubling just to get to the next square, right? So you're doubling 10 more times to get to, from square 10 to square 20. Okay, now if we calculate, so on the 20th square, you could do 2 to the 20th power because you're multiplying by 20 times. So on the last square of the chessboard, there's 64 squares. You're gonna get 2 to the 64th power, that many grains of rice. So go ahead and check and see what that equals on your calculator. Now that number is the way your calculator shows scientific notation. And so what that really means is just one, and I'm going to go ahead and round this just because I don't want all those digits in there, but let's just round it to 1.84. And that 19 is actually your power when the base is 10. So that's what that number is. Now to put that in standard form, you should know that we need to move that number over 19 places to the right of where the decimal is here. So that means that I'm going to have an 8 and a 4. That takes up 2 of those 19, so I'm going to need 17 more zeros. All right, and then I'm just going to put some, now remember this is rounded. I got rid of a lot of those decimals, but so right here we're in millions, billions, trillions, quadrillions, quintillion, so about 18 quintillion, 400 million grains of rice. That's quite a bit. Now that's just on the 64th square, so we actually have to add all the other grains of rice on the rest of it. And to do that, I'll just tell you this, that this expression will represent the total. So it actually would be 2 to the 65 power minus 1. Basically, you're kind of doubling what you had on the last, on the second to last square to get to the last square. All right. Okay, so that so you can see that numbers get really big when we're dealing with exponents, and make sure you understand how your calculator is showing scientific notation because you're going to see that a lot. If it was a really small number, you would see a negative number there in your calculator. All right, so so let's do a problem, and then our goal here will be to try and come up with an equation to represent this. So we have a super ball that's dropped from a height of 1 meter, and it's allowed to bounce repeatedly. Each time it bounces up to 0.8 times the height of the previous. In other words, it's 80% of the height, or we're losing 20%. Those are all kind of saying the same thing. So in the first bounce, you're going to do 1 times 0.8, which is 0.8 meters. Okay, now on the second bounce, you're going to take that last number times 0.8, or I'm going to multiply by 0.8 again, and you're going to get 0.64 meters. Go ahead and fill in the last couple of. Now this table is showing it actually in centimeters. We changed that 1 meter to 100 centimeters, which is no big deal. But so you would fill in on the third bounce, you have to multiply it by 0.8 3 times. And so the expression would be 0.8 to the third power. On the fourth bounce, the expression that would get you the height is 0.8 to the fourth power. And so on the 10th bounce, if you want to just skip to that, the quick way would be multiplied by 0.8 to the 10th power. All right, so go ahead and use that expression to fill in the next few questions here. So whenever a situation is exponential, you can write an expression like this. Take your starting height, which is 100, then multiply by whatever the common multiplier is. And I'm going to put it in parentheses this time, but remember this means times 0.8. And then your power is how many times that thing happens. So in this case, it's the number of bounces. So on the 35th bounce, you would have to do 100 times 0.8 to the 35th power. Go ahead and see what that equals. Notice that's a pretty small number. Personally, I think it probably quit bouncing by then. It's so small. So anyway, so that's what an exponential equation will look like. Let's do a problem here where, and I'll help you create the equation for this. But we're going to start with some medicine, and your body actually gets rid of medicine over time, and that's why if you take like Tylenol, it's only going to last about 24 hours because it's slowly disappearing, and it's disappearing by using an exponential relationship. So so let's put 0 hours. So these are our hours, and this is the medicine remaining here. So at 0 hours, it's going to be the however much medicine you took. Okay. So we're going to start with 100. And then every hour, 1/4 of the medicine is eliminated. That means that we're going to be left with 3/4 of the medicine. And the decimal for 3/4 is 0.75. Basically, we're losing 25%. So to get each hour after this, you're going to multiply your last number times 0.75. Go ahead and do that. So since we are going down, this is exponential decay. And actually, our decay factor is the number we're multiplying by, which is 0.75. We're actually losing 25% every time with the medicine. Now, I rounded these numbers to the nearest whole, so yours might look a little different than that. But here's what the equation would look like. The medicine left is equal to the amount you start with, 100, times the decay factor, 0.75, and then our power is the same as the number of hours. Right? Let's try another one here. It says Kyle saved $500 from a summer job. He plans to spend 1/10 of his remaining savings each week. How much will he have after 1 week? Well, let's decide that. If you're spending 1/10, that means you're spending 10%. We want to know how much you'll have left. So if you are taking away 20% or 10% from your 100%, you're going to be left with 90%. Okay? So you have to figure out what 90% of 500 is. So let's do this here. This is the weeks. This is how much money he has left. Okay? And so he starts with 500. Now to take away 10%, you're going to be left with 90%. So you want to multiply by 0.90. So if you do this first one right, you'll get 450. Go ahead and do the rest of them. So he will have 450 after 1 week. After n weeks, he will have, the expression will be 500 times 0.09 to however many weeks. So they want you to use an n for that. You could use a w also. And since this amount is going down, this is called exponential decay. Okay? So in the definition of exponential growth, it is said x must be greater than 1. So what happens if x is equal to 1? So what they're talking about is this equation. So exponential growth will look like this. Y is equal to some starting amount times your growth factor and to the sum power. Okay, so that's the equation we're talking about. Now it says what happens if x is equal to 1. What they're talking about here is actually the thing you're multiplying by right here. So if it equals 1, your values will just stay the same because multiplying by 1 doesn't change the number. If it's between 0 and 1, you're going to get decay. So we're saying if b is between 0 and 1. Okay, I'm going to put some values in here, and then I'll let you get the equation for those values. So let's just put these numbers for x. And we want a growth equation, which means I need to multiply by a number above 1. And this number I have in my head, and you have to figure out what number I'm using. But I'm going to go like this. And I'm going to let you finish the last two. Now, to figure out what I'm multiplying by, what I would suggest is you divide these two. And if you divide them one way, you're going to get a number less than 1. That would be wrong. If you divide them the correct way, you're going to get a number bigger than 1 because this is a growing situation. And then once you know that, go ahead and write the equation. All right, that's what you should have got for that. We're multiplying by 1.5, and you could figure that out by dividing any number by the previous number. All right, now I'm going to give you a decay. I'm going to give you the values, and you're going to figure out what equation I'm using. Okay, here's the numbers. I'm going to start at 200, and I'm going to go down to 150, and then 112.50. You continue, fill in the rest of them. And again, to figure out what I'm multiplying by, why don't you divide them? Now, since I'm going down, if you divide them one way, you'll get a number greater than 1. That'll be wrong. If you divide the other way, just like you did in the last problem, you should get a number that's less than 1. And keep to figure out what your multiplier is. Go ahead and finish that up. All right, there's the equation you should have got for that one. I think you're ready to do the first day of homework now. Good luck with that, and we'll talk to you soon.